Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rule in computing the derivative of this given composite function. We are 100% sure that this function could be expressed as a composite function because we could see here a rational expression raised to another exponent, in this case, negative exponent. So we can actually write here h of x being x to the power of -4, and our g of x is the rational expression x plus 1 over x. In that case, our f of x is actually h of g of x, which is indicated as this form. This is definition for a composite function because we interchange or we substituted this entire g of x to our x here. That's why, again, it looked like the rational expression is expressed to a power of negative. Now, you can apply here the rule of, or the power of power, where you distribute the -4 to both numerators and denominators and change it into, positive exponents. But of course, our goal here is to differentiate. And since this is a composite function, let us use the rule in differentiating that. We call it chain rule. Our f of x, since this is h of g of x, or further identified as h of g of x, just like this, the first derivative of any composite function according to chain rule is take the derivative of this expression, where we treat this one here as 1, so only using the rule for power, then multiply it by the derivative of your expression or function inside the grouping symbol. So this is what we call as the chain rule. Since our function has a rational expression or rational function, let me have a scratch paper here for some of the important concepts or scribbles before we could solve for the first derivative of this. So let's start with this form, as we are taking the derivative of this, treating this as 1. Okay, so we're going to treat that as 1. Therefore, according to the power, we use n, that's a -4, times this expression x plus 1 over x raised to -4 minus 1, according to the power rule, or the rule of differentiating a power, which will give us -4 times x plus 1 over x raised to the power of -5. Let's stick to this in the meantime, not multiply that nor distribute that here, because we need to also look into the second component of the chain rule, which is the derivative of g of x only for this. And again, since that is actually a rational function, so we're going to use here the rule for rational function, or rule for differentiating a quotient of function. So if this is g of x, let me use here k of x and m of x, where m of x is not equal to 0. So I'm just scribbling this down. If you don't need this, then it's okay, but I'm just scribbling this down as part of a review. So your g prime of x is actually the denominator times the derivative of the numerator minus the numerator times the derivative of a denominator all over the square of our denominator. Okay, so whatever would be our denominator, you square that. We are not yet using the chain rule, but we are getting the derivative of the g of x. So for this function here, our g of x, k of x in this case, because that's our exponent, right? This was our g of x mentioned earlier. So our k of x is x plus 1, and our m of x is just x. So the derivative of k prime of x is 1 derivative of x, okay, because that's 1 x to the power of 1 minus 1 plus 0, or just equal to 1 x to the power of 0, where that is equal to 1. So it's just 1. This is also true with the derivative of x, which is just this component, so it's also equal to 1. With all of this in mind, let us use here our g prime of x, the denominator m of x, x, times the derivative of our numerator 1 minus our numerator x plus 1 times the derivative of our denominator here. So you will have here 1. I will be erasing this so that you will not be confused as being derivative all over the square of your denominator, which is x. So you have your x squared. This will in turn give us x minus 1, as this is distributed times 1 all over x squared. So your g prime of x is negative 1 over x squared. Okay? This is just a component of our chain rule, g prime of x rather, and this is that. Because, as mentioned, f prime of x is this according to the chain rule, g of x prime of x. So this is, writing this, negative 4 times x plus 1 over x to the power of negative 5 times, okay, 1 over x squared as your g of x, or negative 1 over x squared. Okay, now with this, you can multiply them. Positive 4 over x squared, okay, times x plus 1 over x raised to the power of negative 5. I'm okay with this result. Okay, but if you would like to move that further, of course, I'm just going to insert it here. This is not a necessity if your instructor is allowing you to do this, but using the power rule for loss of exponent, this is actually x plus 1 raised to the power of negative 5 over x to the power of negative 5. I'm doing that because my denominator here is x squared, and you can combine that, right? So with combining the two, you will have 4 x plus 1 raised to the power of negative 5 over x to the power of negative 3, or you could just simply exchange them. So you have positive exponents. You have 4x cubed over x plus 1 raised to the power of positive 5. This is also another answer using the loss of exponents, but if this is until here, probably that's already okay. Okay, this is how we solve this expression using the chain rule of involving irrational expression. Thank you very much for watching. So what are you waiting for? Subscribe now.